The biggest AI models in the world don't actually use most of themselves when they answer you. And that's not a flaw, it's the entire point. Here's what most explainers get wrong about model size. People hear trillions of parameters and assume that every single one fires every time you ask a question. That would be a dense model, every parameter active on every input. And for years, that's how things worked. But dense models hit a wall. Doubling the parameters roughly doubles the compute cost. You can't keep scaling that forever. So researchers borrowed an old idea and made it work at a new scale. The idea is called mixture of experts. Think of it like a hospital. A hospital employs hundreds of specialists: cardiologists, neurologists, radiologists. But when you walk in with a broken wrist, you don't see all of them. A triage nurse looks at your problem and routes you to the right one or two doctors. The hospital has enormous total expertise, but any single visit only activates a small fraction of it. A mixture of experts model works the same way. The full model is split into many smaller subnetworks, the experts. Each expert learns to handle different kinds of inputs. Some get good at code, others at reasoning, others at multilingual text. Sitting in front of them is a tiny component called the gating network, the triage nurse. For every input, the gating network scores each expert and picks the top 2 or 4 to actually process the request. The rest stay off. This is what sparse means in practice. A model might have 1.8 trillion total parameters, but only activate 200 billion on any given query. You get the knowledge depth of the larger model at the inference cost of the smaller one. GPT-4 is widely understood to use a mixture of experts architecture. Mixtral, the open source model from Mistral, does too. 46 billion total parameters, 13 billion active per token. That's why it competes with models that look much bigger on paper. The practical takeaway: when you see a model described by its total parameter count, that number tells you its knowledge capacity, not its running cost. The models you use every day are already built this way. Understanding that changes how you evaluate what's fast, what's expensive, and what's actually possible at scale. If that was useful, subscribe. New explainer every week. I'm Ariella.